Hi, it's Mr. T here. In this video, we're going to be looking at calculating net forces, and doing that, we're going to use a concept called vector components. So, what is a vector component? Well, let's assume that we have a force acting on an angle. In this case, it's an angle to the horizontal, 29 degrees. What we can do with that force is we can break down the force into two separate parts. The two separate parts are what we call a horizontal force component and a vertical force component. So the horizontal force component we'll call FH and the vertical FV. So the horizontal force component is a horizontal line that extends as far as our initial vector did, or initial force vector. So it goes all the way horizontally as far as our initial vector, and the vertical component does the same, but it goes the same height as did our initial vector. Now this horizontal and vertical part are called the components. They are the two parts that add up to equal this. Now we can work out the size of the vertical component or horizontal component using trigonometry. So we can rearrange these components and the original force into a right-angled triangle. And now we can see that our vertical component is going to be sine 29 equals our vertical component over 12.5, or we could say our vertical component equals sine 29 times 12.5. We work that out, and that's 11 newtons, our vertical component. Oh, wait, that's our horizontal one. So our horizontal one, of course, because it's adjacent, is cos 29. It's 11 newtons. Our sine one here is 6.1 newtons. Now let's just have a look at these. If I've drawn this angle reasonably accurate, we can see that my vertical component here is going to be smaller than my horizontal, and the answers I've got here seem roughly in proportion, so I'm quite happy with how I worked out those components. Now there's a reason why we work out these components of this vector angle, and that's so we can solve more complex problems. So here's a type of problem that we might have. So here's a suitcase has been pulled by a passenger. So you've pulled a suitcase before with wheels. They're pulling it with a force of 54 newtons and an angle of 42 degrees to the horizontal. What is the horizontal and vertical components? Now the reason why we might want to know the horizontal and vertical components, because the vertical component we could use that along with gravity to work out how much support force was actually being applied to this. And the horizontal component can be used to work out the size of the friction force that's acting against this. So we draw our right-angled triangle, and the red line here is going to be our horizontal component and the blue line our vertical. And remember, our vertical is going to be, we're going to work that out using sine, and our horizontal using cosine. So our horizontal equals 33 newtons. And our vertical equals 36 newtons. Now in this case, what would happen here is if they said that this was being pulled at a constant speed, they haven't said that yet, but if it was being pulled at a constant speed, and we were applying a horizontal component to the right of 33 newtons, there must be 33 newtons of friction going the other way, because it would have to be balanced if it was going at a constant speed. So we can use this idea of components and some other information to solve problems. So here's the technique we use to solve the problems. The idea is we can calculate the net force of something, or we can use the idea of net force. Now net force is the overall force, and the net force is 0. This is a specific case. It means all of the forces are balanced and our object must be at constant velocity. Now constant velocity could either be stationary or moving at a constant speed in a specific direction. So if this occurs, we say that they are balanced, the forces, or we're at equilibrium, if the net force equals 0. When the net force is 0, then all of the horizontal components, only the horizontal components, all of them, must add up to equal 0, and all of the vertical add up to equal 0. So if we can split all of our forces into horizontal components, we know that all of the horizontal components add up to equal 0. The same with the vertical. If we split those and we add them up, we know they'll be equal to 0. So in the car here, if we were looking horizontally, if this was moving at a constant speed, then we would know that the friction force equals the force of the motor. We are told here the car has a mass of 120 kilograms. It's moving at a constant velocity. The addition of horizontal and vertical components of the forces must equal 0. So the vertical force here must equal the gravity force plus the reaction force, and they must equal 0. This wee sigma sign here means the sum of all the vertical forces. The only forces that act up and down ways here are the ones that have some component in the vertical direction, and they're only FR and FG. FR plus FG equal 0. We know, therefore, if we rearrange this equation, well, if we take away this part here, that FG plus FR equals 0, and if we rearrange this here, we know that FR equals negative FG. So if we put down gravity, which is equal to 120 kilograms times negative 9.8, which is negative because it's acting downways, if we do the negative of this, we get the value for our reaction force. I mean, we intuitively knew that our reaction force was going to be the same, but what we can do with this formula is add as many different forces to this vertical or the horizontal one as we need. Let's look at this example. Right, let's look at an example where we might have a bunch of forces, but when they add up, the net force is not equal to 0. So here we've got 3 forces. One of them is horizontal, one of them is vertical, and one of them is a force as an angle, which, remember, if we take its components, it's made up of a vertical and a horizontal force. What we want to find out is if those 3 forces are acting, what is the overall force? Is this object, are the forces acting on this object imbalanced, and if they are, in what direction and what size? So the first thing that we would have to do here is we have to find the components of the force that's acting on an angle. So we can find the horizontal component, remember, by using cosine, and here cosine 42 times the size of this angled force, or the hypotenuse, which is 12.5, gives us 9.3 newtons. So we've got a horizontal force acting to the left of 9.3, and then we've got a vertical force. Let's calculate that from the tension and or from this angle. The vertical force is the sine of this, which gives us a force of 8.4. So remembering that, we know that the vertical forces are a combination of the upwards vertical force, which we just worked out was 8.4, plus the downwards one. And if we make the downwards one by convention negative, we work out that the overall vertical force acting in this situation is 1.4 newtons upwards. We can do the same for the horizontal. The horizontal equals 4.5 newtons plus the force to the left, which by convention is negative 9.3 newtons. And overall, we have a horizontal force of negative 4.8 newtons. What that means is that we now can calculate what the total overall force acting in this system is. So we've taken into account all of our forces, our downwards force, our sideways force, and our components. Now we put these two back together. So we have to the left, which is negative of 4.7 newtons, upwards positive of 1.4 newtons. We can calculate the size of the net force. And if we created a triangle here, what we would find is we know the adjacent and we know the opposite side. So we can calculate the hypotenuse. Or sorry, let's do the angle first. We can calculate the angle using tan theta equals opposite over hypotenuse, over adjacent. Tan equals opposite over adjacent. So the opposite side of our right angle triangle here is 1.4, the adjacent is 4.7. I have to get the tan away from the left hand side, so what I do is I multiply both sides by the inverse of tan, or tan minus 1. I cancel out the tan and the tan minus 1 on the left hand side, and I'm left with theta equals tan negative 1 of 1 over 4 divided by 4.7. This gives me an angle of 17 degrees. So the angle there is 17 degrees, so I've found part of my answer. Now I just want to find the size of this hypotenuse here. And what we can use is we can use Pythagoras' theorem. So the net force is going to equal the square root of the A plus B, which is that C equals the square root of A squared plus B squared. That's Pythagoras' theorem. So we've chucked in our two sides and we can find out the hypotenuse. And the answer we get here is 5.5 newtons. And that is the answer to this problem. Okay, let's have a look at an example of one of these situations where we can use components and the idea of net force to solve a problem. So let's imagine someone's at an airport again. They have a 17 kilogram suitcase and it's been pulled at a constant velocity with a force of 36 newtons at an angle of 38 degrees to the horizontal. Seems quite complicated for a start. Before we start, we can draw a picture of the situation. There it is. Okay. Then from that, or from what we have at the top, we can draw a free body force diagram. So here's our free body force diagram. Notice we've drawn the force of gravity acting on our suitcase. We've drawn our friction force that's acting parallel to the surface but against the direction that it's moving. We've drawn the reaction force or the support force acting perpendicular upwards away from gravity, and we've drawn the tension force acting in the direction that it is being pulled. Also, because the tension force is at an angle, I know that I'm going to separate this into components so I can easily solve this problem. So this angled force is going to be separated into a vertical and a horizontal. So the blue arrow represents the vertical part of the tension force and the red arrow equals the horizontal part. Remember, these are components of a triangle. Therefore, the size of the vertical blue arrow and the size of the red arrow, if we added those numbers together, they would be longer than the tension force. But that's not how trigonometry works. They are two sides of a right angle triangle, and that's why this plus this, because they're at 90 degrees to each other, equals Ft. Now, I can find out the tension force, the horizontal tension force, using cosine, because if I put it here, it would be opposite to the angle of 38 degrees. So cosine 38 times 36 gives me 28, and that looks about right. This looks about 28 if that is 36. And then I can use sine to find the vertical. 22, that looks about right. Its vertical is a bit smaller than the horizontal. And the other force I can calculate here is the force of gravity. It's 17 times negative 9.8 equals negative 167 newtons. So we could start to label these here if we wanted to. What we know is that there are only two components, horizontal components, acting in this free body force diagram. There's the component from the tension force, that's this here, and there is the friction force that is 100% horizontal component. So these two components, the sum, the sigma here represents the sum of all the horizontal forces. These two forces must equal 0 because this is moving at a constant velocity. So they must equal 0. Therefore, when we rearrange this, the friction force must equal negative the tension force. If the tension force here, the horizontal tension force is 22, then the friction is the horizontal is 28, so the friction force is negative 28. So we calculate the force of this is opposite. Now, in this case, using this situation, I'm just using negatives to denote for horizontal left and negatives to denote downwards for our vertical. So let's have a look at our vertical. For our vertical situation here, we have three vectors or forces acting in the vertical. We have gravity, plus we have the component of the vertical of tension, and we have the reaction force. All three of these add up to equal 0. Notice that the blue one at the top here, the horizontal vertical component of tension and the support or reaction force are positive and the gravity is negative. So the gravity plus the reaction plus the tension equals 0, or this reaction force is the one that we don't know, must equal, once I move these two to the other side, the negative of gravity plus the negative of tension. We know that gravity equals negative 167. So the negative of negative 167, we need to do this and the negative of 22. And when I add those two up, I get 145 newtons. Because this force must be that one minus that one, if you think about it that way. Or these two forces must equal the same size of this. So if I was to take my now reaction force and add my vertical tension force, that should add up to the value of my gravity force. And that's how we use components to solve problems, and using free body diagrams and the concept of force, net force equals 0. Yeah, I hope this video has been useful. Just watch out for the next video, and I'll see you then.